Today I'm going to introduce trigonometry and some interesting things that you might be able to use based around it. So first, what is the idea behind trigonometry? It's to use ratios of side lengths and associate them with angles in triangles. So think about this angle right here. No matter how far out you go, you're always going to have that same angle. But the side lengths are different. However, the side lengths are always in a set ratio. For example, if this was A, B, and C, and this is a right angle, you can have this side is something times A, this length here is something times B, and this thing here is something times C. And they're all in a set ratio. And we have different names for these ratios. And they're based around the angle. So sine of that angle theta is going to be the opposite. So AK over the hypotenuse CK. So sine is opposite over hypotenuse. Cosine is going to be the adjacent over the hypotenuse. So the adjacent side, the one touching it, is BK. The hypotenuse, the diagonal, is CK. Or I guess A over C. And this is B over C. And this is cosine is adjacent over hypotenuse. Then you have tangent, which is opposite A over K over the adjacent B over K. So in this case, A over B. And the tangent is opposite over adjacent. So most of the time, people remember it this way, SOHCAHTOA, SOHCAHTOA, as just a way to remember the formulas. Now, these only apply in right angles, but you can use it in non-right angles. For example, the sine of this angle here is going to be the opposite, which is this length right here, over this hypotenuse. So it's not part of the triangle, but you can still use it, provided you can make a right angle. So we'll look at some problems dealing with these ratios and things you might want to realize. First, if sine theta equals 3 over 5. So whenever you see a trigonometric expression like that and you don't see a triangle, you should draw a right triangle and just pick a random theta. It doesn't matter which one. Now we have the sine is 3/5. So according to SOHCAHTOA, so SOH, sine is opposite over hypotenuse. So opposite of 3, hypotenuse is 5. And this is a 3, 4, 5 right triangle, so you can see this is 4. Now what is cosine of 90 minus theta? Well, that means we need to find out what 90 minus theta is. And if we see this is a right angle, and since all of the angles add up to 180, the other angle must be 90 minus theta. So what is cosine of 90 minus theta? So CAH, C-A-H, it's adjacent over hypotenuse. Adjacent to this angle is the 3 side length, and the hypotenuse is 5. Notice that they're exactly the same. So we see that sine theta is the same as cosine of 90 minus theta. And we can see that even the trig identities themselves are related to each other. And of course, because of the right triangles, you can also see that as well. So, first problem, we have 3 over 5. Now, just as an aside, if we have cosine of regular theta, then when we look at the theta angle, see adjacent is this 4 side length, hypotenuse is this diagonal, that's 5. And so we have cosine of theta equals 4/5 for this specific theta. I don't know what this angle is. It's probably something like, 30-something degrees. I'm not sure. But it is some angle. It's like a variable. So for our next problem, we have what is cosine of tangent to the negative 1 5/12? What is this? Well, we have a negative 1. It usually means an inverse function. For example, if you take 3 to the negative 1, that's 1/3, because it is the inverse of 3. If you take the inverse and multiply it by the 3, you get back 1. So in this case, if you take tangent of the arctangent of 5/12, you just get back 5/12. So it's just the opposite of the tangent, and that there's one for all of them. There's an inverse sine and there's an inverse cosine. Now in this case, notice that when you do tangent of an angle theta, you get a ratio, and if you do tangent inverse of the ratio, then you get an angle theta. So in essence, we're saying what is cosine of that angle that gets the 5/12 ratio. So we can draw another right triangle, and let's say that tangent inverse is theta, just for ease. Angles are usually theta. We'll say this theta makes the ratio 5/12. So tangent, TOA, is opposite over adjacent. And this is a right triangle, so it's easy to see this is 13 with the Pythagorean theorem. And we want to say, what is the cosine of this angle? Now, tangent inverse of 5/12 gives you back the angle. So then cosine of that angle. Cosine is adjacent over hypotenuse. Adjacent is 12. Hypotenuse is 13. So we get 12/13. And that is our answer. Trigonometry is something you learn pretty late in high school normally, but it frequently shows up in competition type maths and in higher level math if you do go into that. So it is a very important thing to be familiar with and to understand. So hopefully this serves as a little bit of an introduction into the kinds of thinking that might help you in competitions, as well as kind of introduce what they are. If you would like more information, you can always Google trigonometric identities or trigonometry, and you can probably find a lot of things on the internet as well.